Hi, everyone. Uh, I'm back again. Today, I'm going to talk about a retrieval augmented generation, that is a RAG application about gestational diabetes. My application, I called it Digital GDM Screen, and my name is George Semaganda, and I'm a student, computer science student from Makerere University. Yes, I'll dive straight into the contents of the presentation: the introduction, background and related works, methodology, application, experimental results, case studies, discussions, future works, conclusions, and references. The introduction. About 382 million people around the entire world live with gestational diabetes. That's 2023. That is a diabetes atlas from 2013. Then gestational diabetes are mellitus defined by the World Health Organization as a carbohydrates intolerance causing hyperglycemia during pregnancy is a rapidly growing concern. In 2021, gestational diabetes mellitus affected 16.7% of pregnancies globally. Then gestational diabetes mellitus poses significant short-term and long-term health risks for both mothers and children, including a 50% risk of developing obesity and type 2 diabetes later in life. So, what is the purpose of my RAG application? To provide accurate gestation diabetes health information to help pregnant women uh, manage uh, their conditions, support medical workers through recommendations, and enhance awareness to improve health outcomes. These are some of the related works I referred to as I was doing my research. So basically, this is a methodology. I have a corpus that I curated. Basically, it was PDFs from Google Scholar, which PDFs I had to convert into text, after which I had to clean, visualize, and do EDAs onto them. And then I got a corpus, a cleaned corpus that I again encoded. So how does this system work? Is I have a user interface where a user prompts the application. Then if a prompt comes through, it there is a smart retriever that uses sentence transformers that moves the embeddings through the embeddings files to the encoded corpus, and then to retrieves chunks that are then combined with the original prompt. And then the original prompt, remember, this retrieval is done using cosine similarity, and then the retrieved the I mean the prompt combined with with the relevant chunks are then sent to the large language model. For my case, it's the OpenAI GPT-4 that then retrieves in context to what my RAG application is doing, and then it is in position to give feedback through the UI design. So problem definition, like gestation diabetes are marked by high blood sugar during pregnancy, present significant risks such as preeclampsia, premature birth, and long-term health issues for both mothers and the baby. So many pregnant women face lack of reliable and timely information on managing this condition, which results in poor disease management uh, uh, and and health complicated health risks. So this is my system architecture. Still, I have my curated corpus about the gestation diabetes. I have my embeddings model that through which I get embeddings model that are compared with a query or a prompt by the user, and then the query is then remember we have our smart retriever that uses sentence transformers that retrieves chunks of data from the for example, this is a vector database that again is combined with the original prompt and sent to the the large language model. For our case, it's the OpenAI GPT-4, and then there's a response that is in context with the corpus. Remember the corpus that is in the dataset, and then this chunk is again output to the user interface. So basically, that is the architecture design. So implementation details are, I'm using Flask for my app development, where I have modules, the app, the templates, the static files, and then the test files. So the key functionalities include data loading. This includes both the clean dataset and then the embeddings.nyp. Then there is contextual retrieval. This is the one that uses the cosine similarity, where cosine similarity basically works with the vectors that are non-zero, and the result, the similarity comes in when I have two vectors. I get the dot product of those two vectors. I again divide by the product of the magnitude of both vectors, and after that I get my response generation that is given back to the user. So my experimental results are okay. The environment, I'm using a chip that is Apple M1, Mac OS 13.0, and then RAM 8 GB, SSD 256. Then the tools, I'm using Flask, sorry, sentence transformers, Open AI API, and Python. So the data set is a cleanly curated data set that is that a corpus that is related on gestational diabetes, and then embeddings, an embeddings file, that is the embeddings.nyp. So the testing methodology I'm using is I get the deployed Flask app locally, then I have an tests.py file that I could submit that has this number of queries related to gestation diabetes, and I measure the response accuracy, relevancy, response time, and then system performance. So the evaluation matrices I am considering, I considered is the accuracy, relevancy, response, and response time. So the results are the performance results. There are three key observations. The accuracy, my bot achieved a relatively high accuracy rate, indicating reliable information delivery. Then relevancy, responses were highly relevant to the session diabetes queries, reflecting effective context retrieval and augmentation. Then the response time, I tested with 10 prompts. I have a file, a CSV file is attached, and then the average response time for all the prompts was 10.3. This is the average after I got everything else. So if I look at the case studies, I have a number of case studies. For example, this is the first prompt. So I was asking my app, who are you? And then this was the response. I'm an AI assistant specialized in providing health information, specifically on the topic of gestation diabetes. I'm here to provide accurate and information responses related to this health condition. So that's other case studies. What should I do if my blood sugar levels are higher than normal during pregnancy? So, and the response here, if your blood sugar levels are higher than normal during pregnancy, it's important to seek medical advice, as you may have gestation diabetes and so forth and so on. So this is another case study. What are the risk factors for developing gestation diabetes? And then how can I manage my diet to control blood sugar levels and their respective responses? Another case study of what medications are commonly prescribed for type 2 diabetes, and then how often should I monitor my blood sugar levels, are all case studies. So the benefits from my study is there's accessibility, which provides instant and reliable information about gestation diabetes. Then personalization. Remember that prompts are tailored to a user requirement, and this is in context to gestation diabetes. And then support, offers practical support and advice and emotion support for pregnant women. Then efficiency, it quickly retrieves, because for my test I had an average response time of 10 seconds. Then the challenges, The development complexity, integrating the RAG framework and then the OpenAI was a little bit of a challenge. Then data handling, ensuring quality relevancy of the scripted data was also, a lot. Then response accuracy, then balancing accurate responses with diverse queries was also complex. So the future works I'm looking at is uh, enhancements to improve response accuracy and then reduce more further on the response time, which was 10 seconds. Then new features, I'm thinking I can integrate more interactive features such as live consultations and more navigation features for the UI designs. Then I can as well expand and explore, applying the bot to the medical, applying the bot to other medical conditions and domains. So, in conclusion, the bot effectively uses the RAG framework to provide accurate, relevant information about gestation diabetes. Uh, Remember, I'm using a large language model for retrieval. Then, the benefits include accessibility, personalizations, while challenges involve technical complexity and data quality. Then, future works will focus on enhancing features and expanding to other medical fields. Then these are the references and then acknowledgement. I want to thank my internship supervisor, that is Mr. Galiwango Marvin, for the guidance and helping out throughout the entire process. Uh, Thank you. In case you have any questions, feel free to drop it in the comment section and I'll really be glad to respond. Thank you so much.